When we left off, we talked about alcoholic fermentation, and I did make a bit of an error that I wanted to correct. So if you'll just flip your sheet over real quick and let's talk about that error. And that is essentially the ATP produced in lactic acid fermentation and in alcoholic fermentation is all produced in the glycolysis portion. So essentially, it only produces 2 ATP. The advantage of converting that pyruvate to lactic acid or alcohol is that it does release these high energy compounds like we talked about right here. And so it allows glycolysis to continue to go through. So only 2 ATP are created. All right. So now I want you to go back to the front and we're going to add our next step of cellular respiration. Now, just as a review, remember in glycolysis, we took that sugar and we made 2 pyruvates, 2 ATP, and I forgot those high energy compounds. Okay, so that is our formula for glycolysis. So now we're going to move on to step 2, which is the citric acid cycle. But before we can go into the citric acid cycle, we have to change this pyruvate just slightly. So now I'm going to draw essentially a mitochondria. And a mitochondria, remember, looks kind of like a bean. And so I'm just drawing that really large because everything is going to go in my bean. All right. And so this is the mitochondria. Now, our pyruvates that we made in glycolysis are going to diffuse to the mitochondrial matrix. And what's going to happen here is that little tiny step called pyruvate oxidation. And what's going to happen is we're essentially going to add an oxygen and then take off a carbon. So what I did here was I added in 1 oxygen for each pyruvate, and then I grabbed a carbon and made carbon dioxide. So remember, this right here is 2 carbon dioxides, and those are going out. Now, how do we get that carbon dioxide out? We breathe it out. All right, we release it out into the atmosphere using our lungs. And what we are left with is a two carbon compounds called acetyl-CoA. All right, so we added 2 oxygen in, we got 2 carbon dioxide out, and we ended up with 2 acetyl-CoAs, which are 2 carbon compounds. Now, please notice that we had to use oxygen here. So this is truly aerobic respiration. So I just wrote a little formula out to the side. I'm not ever going to ask you to write out the formulas, but for me, the formulas are good to show exactly what is happening at each step. So we took our 2 pyruvates, we added 2 oxygen. Those 2 oxygen grabbed a carbon and ran off with it. So we had 2 carbon dioxide that we breathed out. And that left us with two carbon compounds called acetyl-CoA. At this point, we are ready to start the citric acid cycle. All right, so the citric acid cycle is called a cycle because it begins and ends with the same thing, which is citric acid. So citric acid is going to cycle up here and combine with acetyl-CoA. And so what you'll end up with are the 3 carbons from the citric acid and then the 2 carbons from the acetyl-CoA. Now, once we do this, our goal essentially is to get rid of all of the carbons from that acetyl-CoA and make energy out of it. So we are going to use oxygen to do that. So I brought in oxygen. I grabbed one of those carbons and I attached it to the oxygen to make carbon dioxide. And in the process, I actually made some high energy compounds. So now let's do it again. All right, if you'll see here, I added a carbon to citric acid. I should have drawn 4 carbons. So basically what happens is we get that 2 carbons from acetyl-CoA. It is attached to the citric acid. We are going to bring in an oxygen, grab a carbon, release that carbon dioxide. We're also going to get some high energy compounds. The second time we do that, we add in the oxygen, release the carbon dioxide. We're actually going to make some ATP here. So that's good. And then we are also going to, something has to happen with the citric acid, which I'm not getting into, but there's a little bit of a chemical change to create the actual citric acid, and that also releases high energy compounds. So now it's time to make a formula. We started with 2 acetyl-CoA. Now, when I just did this cycle, I only did it for 1 acetyl-CoA. All right, but each acetyl-CoA is going to go through this separately. So we start off with 2, which means we actually used 4 oxygen instead of the 2 you see here, because this cycle is going to go twice. So 2 oxygen, and what we ended up with was 4 carbon dioxide, because remember, the acetyl-CoA has to go through twice, plus some high energy compounds, and a couple of ATP. All right, not a lot, anywhere between 2 and 4, depending. Usually I just say 2, but some places they'll say 4. Either way. So that is the citric acid cycle and pyruvate oxidation.